In this lecture, we are going to start sign of quadratic expression. Sign of quadratic expression, we have to remember few points on this. Like if the quadratic is given ax square plus bx plus c, and we have to determine this is positive or negative. So first thing you have to remember, if del means the discriminant b square minus 4ac is less than 0 for x belongs to R, means for any values of x, if this is less than 0, then the quadratic ax square plus bx plus c is positive, then a will be positive, or vice versa. Or if a is negative, the quadratic ax square plus bx plus c will be positive, and if a is negative, this expression ax square plus bx plus c will be negative. Both will be same sign. But if del is equal to 0 for x belongs to R minus, because at the value of minus b by 2a, the expression y is equals to ax square plus bx plus c will be 0, right? So other than this value, right? Other than this value, again, the sign of a and the expression y is equal to ax square plus bx plus c will be same. But the case when del greater than 0 means this having two roots, right? And we are like supposing there both the roots alpha and beta is there, alpha is less than beta, one value will be less than the other, right? We have already taken when two values are equal, right? Alpha roots are equal roots, so we have taken in second case, right? Then in this case you have to divide this into two parts. In between the roots means between alpha and beta, the quadratic ax square plus bx plus c and a have opposite sign. If this a is positive, then ax square plus bx plus c will be negative. This is for between the roots. But when we are going beyond the roots, maybe for greater than beta or less than alpha, right? Then again the sign of ax square plus bx plus c and the sign of coefficient of x square will be same. You must remember these cases, right? Very useful while solving the questions, right? So in nutshell, right, few important points are there that you have to remember. Like if we are taking y is equal to this, or fx is equal to ax square plus bx plus c, this will divide into two factors if alpha and beta are the roots, x minus alpha into x minus beta, and a is a factor of this, right? Alpha less than beta. So remember this case, a greater than 0, if x will be greater than 0 beyond the roots, means going from beta to infinity or minus infinity to alpha, right? Second, this will be 0 for alpha and beta will be 0. And third case, between the roots, this will be of negative sign. This is the case for a greater than 0. Similarly, for a less than 0, this will be going for between alpha and beta, the sign will be opposite of these two. A is less than 0, then fx must be greater than 0, and fx will be 0 for alpha and beta, and fx will be less than 0 when we are saying going beyond the roots, right? Greater than beta or less than alpha, right? But in graph we can understand this very easily, and we can use the graph also. So now we are starting the graphical representation of quadratic equation ax square plus bx plus c, right? If we have to draw the graph, few things we have to remember, right? This is the parabola. If we are writing this y is equals to this, or fx is equal to this, fx is equal to this, or y is equal to this, right? Y is the function of x, or fx, x is variable, then we are getting ax square plus bx plus c, right? Case first, when a is greater than 0, the parabola will be upward parabola. It could be anywhere if the axis line is given, right? Like this is the axis. It could be anywhere. It can intersect the y-axis anywhere, but it may or may not be cutting the x-axis or not, right? But if a is greater than 0, this will be upward parabola going up, right? This will be upward parabola for a greater than 0 now. But if we are taking the case of a greater than 0 as well as the discriminant d greater than 0, discriminant d greater than 0, right, give you the two roots or two distinct roots. So this parabola must intersect the x-axis at 2 points, right? X-axis at 2 points, maybe both will be positive, right? In this case, if both the roots are positive, you have to remember this. If both the roots are positive, so we can say alpha plus beta means sum of the root will be positive, and also the product will be positive, right? But in the second case, when one root is going for positive and other root is going for negative, so in this case we know that the roots, if I am writing alpha plus beta, so if it is not given alpha plus beta, it's very difficult to say that this will be positive or negative. But 100% we are sure in this case that alpha into beta will be 100% negative. But you have to remember, if it is given one root is positive, other is negative, and this you have to understand this language. What they are saying, mod alpha greater than beta. Mod alpha greater than beta means magnitude of alpha is greater than beta. So the negative one is greater than the positive one. So overall, in this case, the sum of the root alpha plus beta is coming as negative, right? In the same case, maybe both the roots will be negative. In this case, again alpha plus beta, sum of the root will be negative, and alpha into beta will be positive, right? Will be positive. Now, again, if I'm going for a greater than 0 and del is equals to 0, right? D is equal to 0 or del is equal to 0 means this graph touches the x-axis, right? This touches the x-axis and upward parabola. So very simple to draw the graph, but it may be in the positive side, it may be at 0, it may be at negative. It's not given from there, right? We can't deduce key which one will be the graph, more information required for that. But the best example is this one, when we are saying a greater than 0 and d the discriminant less than 0. Discriminant less than 0 means this graph will not intersect the x-axis. So this will be upward parabola, or it will not touch or intersect the x-axis. So see, there is a gap, right? It will be in the positive one, right? But it can move to anywhere in the positive side or the negative side or in between the axis, right? Now, we are going for case 2 when a is less than 0. A less than 0 will give you the downward parabola. Why this is so? You can think in this way, ax square plus bx plus c, right? This is why if a is negative, we know that x square will be always positive for any greater values. If I am saying x is very large value going to infinity, right? Infinity into the negative of a, that will give you the answer minus infinity. Thus the reason this is downward parabola, right? Now, with the downward parabola, if again we'll go with discriminant greater than 0. So this will intersect the x-axis in two distinct points. Maybe both the point will be in the positive, or one positive, one negative, and both negative. Both roots are positive, so sum will be positive and product will be positive, and so on, right? Directly we have already seen that how to use the concept of this, right? If a less than 0, del is equal to 0, this will touch the x-axis and this will be downward parabola, and we can draw this in all the three manners, right? Simple. So just try to draw this for a less than 0 and del or d less than 0, discriminant less than 0. This will be the parabola lying completely below the x-axis. It could move to anywhere, right? It can move to anywhere in between. It may be the vertex. This is called the vertex, right? This vertex may be at the positive, negative, or this will intersect at any other point, right? This vertex, any vertex is known as minus b by 2a and minus d by 4a, right? You have to remember this, very important, and we have to use this also. So you have to remember this, this vertex, right? In this case, the x-axis and y-axis. So x is always 0 in this case, so b will be 0 in this case. But in this case, minus b by 2a will be positive, and in this case, x is negative, so minus b by 2a will be negative. It depends on which quadrant this will be, right? So now the application part of this, and one of the most important topic in quadratic, is location of roots, right? So in this portion, right, they will ask that the quadratic ax square plus bx plus c is given and the roots lies in the interval. Then we have to find the condition or apply the condition on a, b and c. So we are starting with alpha and beta are the roots of the quadratic equation. Alpha is less than beta. Just suppose case first, both the roots are positive. If both the roots are positive, so obviously we know that, right, sum will be positive as well as product will be positive, right? The vertex is minus b by 2a and minus d by 2a, right? If this touches the x-axis, minus b by 2a will be 0. So first case, right, you can see from both this, d, the discriminant will be greater than or equal to 0. Second case, sum of the roots will be positive, so minus b by 2a or minus b by a, sum of the root is, right, positive. And this a into f0, you have to understand this, right? The quadratic is given ax square plus bx plus c, right? This is the quadratic, and this quadratic is represented as f of x. Now, if you are putting x is equal to 0, so you are getting f0 is equal to some constant c, multiplying with a, so a into c, the sign of a and c. You can see the sign a is greater than 0, and this will intersect somewhere there, y-axis. So above the, right, above the x-axis, so this y is positive, and in this case also, if this will intersect somewhere, so this y will be positive. So both case c, this point will be c. If you are putting x is equal to 0, you are getting y as c. So this is 0 comma c, so this will be positive. That's the reason we are writing this is a into f0, right? This is very important point. We have to use this, right? Right? But second case, when a is less than 0, downward parabola will be there, but you have to use only these three conditions, right? Again, you have to use these three conditions for that, right? So let's go into the second one. Again, if both the roots are negative, right? Look, everything will be same. First, discriminant greater than or equal to 0, sum of the root less than 0, a into f0 must be greater than 0, right? So in this case also we can say we are getting all the three same results, but for negative values. And if a less than 0, there will be a downward parabola, and but the condition for this will be same, right? Condition for this will be same, right? If roots are of opposite sign, if both the roots are of opposite sign, one is positive, other is negative. So obviously for greater than 0 and less than 0, we can see del greater than 0, product of the root less than 0, one is positive, one is negative. F0, again we know that these two are the same condition, right? And del, it's not necessary always you have to take del, because if one root is positive, other is negative, so del must be always greater than 0. Think why? But the graph for a greater than 0 is given there, and a less than 0 is this case, right? So now we are starting with like taking the value k. We are saying both the roots are greater than some value k, right? So if this is the parabola, this will intersect the x-axis at alpha and beta, and now we have a value k. So there is a value k, both the roots alpha and beta must be greater than k, then we have to find condition. Very simple, only you have to concentrate on the graph, right? Maybe this d will be greater than 0, or maybe d equal to 0. In both the case we can say, right, both the roots, the roots minus b by 2a is only, right? So both the roots greater than k, and in this case also both the roots greater than k, right? So now the first condition will be del or d will be greater than equal to 0. The second will be alpha plus beta, right, sum of the root. We can say sum of the root is, or this alpha plus beta is minus b by a, that will be greater than 2k, right? Or we can say, think in this way, like vertex minus b by 2a, right? Vertex minus b by 2a is going ahead, so minus b by 2a is greater than k in both the case, right? And third, if you are putting k on this graph, you are getting this above the axis. So this is positive, and a we have taken as upward parabola, so we have taken as a positive. So this is the case, right? But remember, while solving these three, right, if you are getting three values or three condition on that, the intersection of all three, right, intersection of all, right, will be your answer, right? Intersection of all means from first you are getting answer 2 to infinity, right? From second, let you are getting the answer 5 to infinity, right? From third you are getting the answer minus 5 to 7, right? So what is the meaning of intersection? Draw the number line. First, let this is 2 to infinity, right? Second, it's coming 5 to infinity, and third it's coming somewhere minus 5 to 7, right? So you have to see which portion is common to all three, right? Which portion is common to all three? So the answer is only 5 to 7. So remember, you have to take intersection of all three, right? And this we have seen for a greater than 0. For a less than 0, only 1, 2, 3, these three conditions you have to apply, right? Now, so the next case, both the roots are less than k, almost the same thing, right? Both the roots are less than k, alpha and beta are same, right? Conditions are same. The application part, the first will be same, so d greater than equal to 0. The second will be alpha plus beta. Obviously, in this case, we can say both the roots are less than k, the mid value, right, minus b by 2a, if you will transfer 2 here. So you can say minus b by 2a is less than k also, right? This is true. And the third, a into f0, right? F a into f0, that was for both the roots are positive and negative. For this case, this is a into fk. If you'll put this k on the quadratic, this fx is equal to ax square plus bx plus c. So in this you will put the value k, right? Then a into fk greater than 0, again you will get the same thing, right? For a less than 0, you will get the same condition on this, right? Next, k lies between the roots. One of the best example is k lies between the roots. Obviously, we can't take this as touching the x-axis, right? We have already seen that both the case we can see the k is lying between the roots. So if a is positive, fk will be negative. If a is negative, fk will be positive. So a into fk will be negative. You can or cannot take the case of del. Both way this will be same. But remember this, right? The next case on this, exactly one root is lying between k1 to k2. Beautiful example of this, right? One is k1, other is k2. Let alpha is lying between k1 and k2 in first case, and in second case, let beta is lying between the roots. So first we have to start with del greater than 0, right? Because one value has to be there, right? And fk1, fk2, the product will be less than 0. That will be the sufficient condition for you. Only two things you have to take in this, right? Note down everything carefully. You have to use this concept for your questions, right? Next case, both the roots lying in the interval alpha and beta, right? So in this case, del greater than equal 0, right? Both the roots is lying in the interval of k1 and k2, right? So d greater than equal to 0, you can see why d greater than equal to 0, it will intersect or touch the axis a into f of k1 greater than 0 as well as a into fk2 individually you are taking, and minus b by 2a. This value is lying between k1 and k2. Both the cases are applicable for a greater than 0 as well as for a less than 0, right? So all the cases are there. Now if I'm saying k lies between the roots, right? If k is lying between the roots, how we have to go for this, right? In this case, we are saying both the k lying between the roots, so k1 and k2 both lying between the roots. So no worry, that same case as we have already taken as k lies between the roots, right? So these are the conditions for our location of roots. But when we have to find extremum value, right? When we have to find extremum value of ax square plus bx plus c, right? One of the best example for this we can say is if this is given y is equal to fx in this form, we know that the vertex we can find for a greater than 0, right, or less than 0, we know that this will be the vertex and that will be minus b by 2a, right? And minus b by 2a minus d by 4a, you are getting the answer for this, right? But if we are going for a less than 0, that will be the maximum value because the parabola will be downward parabola, right? So in downward parabola, but when we have to find the maximum and minimum value, so one of the method is this one, but we can also apply this as y is equals to 12x minus x square minus 32, or we can make the quadratic as x square minus 12x plus 32 plus y, right? Transferring this is equal to 0. Discriminant of this, a is 1, coefficient of x square, b is 12, and c is 32 plus y. So discriminant of this is b square minus 4ac must be greater than 0 and equal to 0, right? This is one of the best example. If you have to find minimum or maximum value of any quadratic, go for this, you'll get the value of y, right? Or you can apply the basic formula what we have seen in the question, but this is the best method when you can apply this for not only for quadratic, right? Y is equal to quadratic. Also you can use this for linear upon quadratic, or you can use this for quadratic upon quadratic, right? So cross multiply this, make the quadratic, like if it is given y is equal to x upon x square plus 1. So multiply this, y into x square plus y is equal to x. So y into x square minus x plus y is equal to 0. So d, so a is y, b is minus 1, and c is y. So d greater than equal to 0. Again you can apply b square minus 4ac greater than equal to 0, or easily by factorization you can get the value of this, right? So if we have to find minimum and maximum value, this is one of the best method. We can apply this in the question itself, right? Now we have to see how to use our graph to solve the question. So in next lecture, we will see how to solve the question when we have to apply the graph, and in the question itself, we will take how to solve the question of location of roots.